This video introduces the differentiation of basic hyperbolic functions. We will need to revisit the definitions of sinh and cosh functions, and then we can write down all the other functions in terms of sinh and cosh functions, and after that we will do the differentiation. We know sinh function, hyperbolic sine x, is defined as e to the x minus e to the negative x, all of that's divided by 2. We know hyperbolic cosine x, cosh x, is defined as e to the x plus e to the negative x, all of that's divided by 2. And then we defined hyperbolic tangent x, tan x, as sinh x over cosh x. And we will also look at the other definitions. We defined cosh x, hyperbolic cosecant function, as 1 over sinh x, 1 over hyperbolic sine x. And then we defined sech x, hyperbolic secant x, as 1 over cosh x, 1 over hyperbolic cosine x. Finally, we defined coth x, hyperbolic cotangent x. It was defined as 1 over tan x, 1 over hyperbolic tangent x. Using these definitions, we can easily differentiate these functions. So first we will do the differentiation of sinh x. Y equals sinh x. We need to differentiate this function. We need d by dx sinh x. We can simply differentiate sinh x by writing down the definition of sinh x, which is e to the x minus e to the negative x, all of that's divided by 2. The 2 in the denominator is a constant, therefore I can factor that out as a 1/2, and then I simply need to differentiate the numerator. When you differentiate e to the x, it will be just e to the x, and then I have minus sign. Then I need to differentiate e to the negative x. How do you differentiate e to the negative x? It will be e to the negative x times negative 1. Why is that? Because if you have to differentiate e raised to a function f of x, we know this is equal to e raised to the function f of x times f prime x, where f prime x is the first derivative of f of x. When you look at e to the negative x, that f of x is negative x. When you differentiate that negative x, it's going to be negative 1. Now we can simplify this one. It's going to be equal to 1/2 times e to the x plus e to the negative x, which you can see as e to the x plus e to the negative x divided by 2. What is this function? This is hyperbolic cosine x. Therefore, we have established our first result. If you differentiate hyperbolic sine x, sinh x differentiation with respect to x is equal to hyperbolic cosine x, cosh x. That's our first result. Now we will see how to differentiate hyperbolic cosine x. Y equals cosh x. I need d by dx cosh x. d by dx, we defined cosh x as e to the x plus e to the minus x divided by 2. Once again, the 2 in the denominator is a constant, which I will factor out as a 1/2, and then I simply have to differentiate the numerator. If I differentiate e to the x, it's going to be e to the x. Then I have plus e to the negative x times a negative 1. This is equal to e to the x minus e to the negative x, all of that's divided by 2. And what is this function? That function is hyperbolic sine x. So we have established our second result also. If you differentiate hyperbolic cosine x, cosh x is differentiated with respect to x, you get sinh x, you get hyperbolic sine x. Please note that if you differentiate cosine x, you get a negative sine x. However, if you differentiate hyperbolic cosine x, you do not get a negative symbol. Hyperbolic cosine x differentiation is equal to positive hyperbolic sine x. Now we will see how to differentiate y equals hyperbolic tangent x, y equals tan x. We need to differentiate d by dx, hyperbolic tangent x, tan x differentiation. I'm going to write tan x as sin x over cosh x, hyperbolic sine x divided by hyperbolic cosine x. This is what I need to differentiate. It's a quotient, which means I need to apply the quotient rule. I need to label one of them as function f, the other function as function g, and then I will need f prime and g prime. We already found f prime. F prime is the derivative of sin x, which we proved as cosh x. Also, we found g prime. We differentiated cosh x, and we saw it's equal to sin x. Now I can apply the quotient rule. So what's the quotient rule? If I have a quotient f over g to be differentiated, we know this is going to be equal to g times f prime minus g prime f, all of that's divided by g squared. When I apply that, this is going to be equal to, in the denominator I have a g squared. Since g is equal to cosh x, the denominator will be cosh squared x. The first term is g times f prime. G is equal to cosh x. F prime is also equal to cosh x. So it's cosh x times cosh x, which becomes cosh squared x. And then I have this negative symbol minus, the next term is g prime times f. G prime is equal to sin x. F is also equal to sin x. Therefore, g primes times f should be equal to sin squared x. Now you need to tell me what is cosh squared x minus sin squared x. This is the Pythagorean equivalent of hyperbolic functions. That numerator should be equal to 1. During our last discussion, in which I introduced the hyperbolic functions, I also discussed the 3 forms of the Pythagorean identities for hyperbolic functions. In that video, we saw that all of this is equal to 1. Hyperbolic cosine squared x minus hyperbolic sine squared x is equal to 1. If you cannot remember this result, I'll have a link posted down below in the description for that video. Alright. Because of that reason, this simplifies to become equal to 1 over hyperbolic cosine squared x. We know 1 over hyperbolic cosine x is equal to hyperbolic secant x. Therefore, this reduces to hyperbolic secant squared x, sech squared x. Let me write down that result. If you differentiate hyperbolic tangent x, tan x differentiated with respect to x, you get sech squared x, hyperbolic secant squared x. Please note that all the first 3 hyperbolic functions, hyperbolic sine x, hyperbolic cosine x, and hyperbolic tangent x, if you differentiate any of these functions with respect to x, your answer is positive. Now we are going to look at the reciprocal identities. The first reciprocal hyperbolic function is cosh x. So let me take y equals cosh x. Now I need to differentiate this function. When I differentiate cosh x with respect to x, I will write it down as d by dx. Cosh x is 1 over sin x. How do you differentiate that function? We may use the power rule or we may use the quotient rule. In fact, the quotient rule is a little bit unnecessary because this numerator is a constant. Therefore, I'm going to simply use the power rule. I can rewrite this function as d by dx sin x raised to the negative first power. That's the one I have to differentiate. So how do you apply the power rule for this? Remember the power rule, if you have to differentiate f of x raised to the power n, the derivative of that is equal to n times that same function f of x raised to the n minus first power times f prime x. So I need to identify sin x as my function f of x, and n is equal to -1. Now we will apply the power rule and differentiate that. When I differentiate it, I get n times f of x raised to the n minus first power. Since n is equal to -1, it's going to be -1 times sin x raised to the negative second power times f prime x. Fx is sin x. The derivative of sin x is equal to cosh x. So this can be simplified this way. Negative cosh x on the numerator. In the denominator, I have sin x squared. I can look at this function as cosh x over sin x times another 1 over sin x. And also do not forget this negative symbol. So this is equal to, there's this negative symbol. Cosh x over sin x is equal to hyperbolic cotangent x, coth x. And there's one more sin x term remaining in the denominator. 1 over sin x is hyperbolic cosecant x, cosh x. That's your result of the derivative of cosh x. Let me write it down. If you differentiate hyperbolic cosecant x with respect to x, your answer is negative coth x cosh x. The first reciprocal hyperbolic function has a negative derivative. Remember that. Next, we will look at the second reciprocal hyperbolic function. So the next reciprocal hyperbolic function is y equals sech x, which is hyperbolic secant x. I need to differentiate this function, d by dx, sech x. I'm going to write down this function as d by dx 1 over cosh x, 1 over hyperbolic cosine x. And I can see this function as d by dx cosh x raised to the negative first power. Once again, using the power rule, I can differentiate this function as -1 times cosh x raised to the negative second power times the differentiation of cosh x, which is sin x. Now we can simplify this one some more. This is going to be negative sin x on the numerator divided by cosh x squared in the denominator. Just like earlier, I can identify sin x over cosh x as tan x, and there's one more cosh x term remaining in the denominator, which I can write as negative tan x times 1 over cosh x is sech x. Therefore, we have established that next result as well. If I differentiate sech x hyperbolic secant x with respect to x, we get negative tan x times sech x. Please note that the second reciprocal hyperbolic function also gave us a negative answer. If you differentiate secant x with respect to x, your answer is tangent x secant x, which is a positive answer. However, if you differentiate sech x hyperbolic secant x with respect to x, your answer is negative tan x times sech x. You can see this same characteristic of the derivative being negative even if you go for the hyperbolic cotangent x. However, this is very routine, therefore I'm not going to discuss hyperbolic cotangent x with you, but I will assign it as a homework. If you need to differentiate hyperbolic cotangent x, consider writing that as hyperbolic cosine x divided by hyperbolic sine x, and then you can simply use the quotient rule. To simplify that, you will need one of those 3 Pythagorean identities for hyperbolic functions. If you have any questions, please let me know. If you do all the things correctly, your final answer for the derivative of coth x d by dx hyperbolic cotangent x, this final answer should be equal to negative cosh squared x. Please do not just go ahead and write down this answer in your homework. please write down coth x as hyperbolic cosine x divided by hyperbolic sine x, and then clearly identify f and g, and then use the quotient rule correctly. And then finally simplify and show that it's going to be equal to negative hyperbolic cosecant squared x. Thanks.